Welcome to another episode of AP Computer Science. Be ready to take notes on Boolean Algebra. Conditional loops often prove to be one of the most difficult control structures to work with. This lesson will give you more strategies that can be used for defining the beginning and ending conditions for loops in your programs. A Boolean assertion is simply an expression that results in a true or false answer. For example, A is greater than 5, or A is less than or greater to B. To negate a Boolean assertion means to write the opposite of a given Boolean assertion. For example, given the following Boolean assertion noted as A, the corresponding negated statements result in supplying the not operator to A. Notice the negations of Boolean assertions can be used to rewrite code. For example, if not x is less than 5, the statement can be rewritten as if x is greater than 5, do some code. This is important because we understand positive statements much more easily than statements that contain one or more nots. Boolean algebra is a branch of mathematics devoted to the study of Boolean values and operators. Boolean algebra consists of fundamental operands and operators, true and false for operands, and, or, and not for operators. There are many identities which have been developed to use with compound Boolean expressions. Two of the more useful identities are De Morgan's laws, which are used to negate compound Boolean expressions. Morgan's laws. The symbols A and B represent Boolean values, true or false. Here's a good way to think about De Morgan's laws. Notice that it's similar to distribution postulates in mathematics. The not operator is distributed through both terms inside the parentheses, except that the operator switches from and to or vice versa. The casino game craps involves rolling a pair of dice. The rules of the game are as follows. If you roll a 7 or an 11 on your first roll, you win. If you roll a 2, 3, or 12 on your first roll, you lose. Otherwise, rolling a 4, 5, 6, 8, 9, or 10 establishes what is called a point value. If you roll a point value before you roll a 7, you win. If you roll a 7 before you match the point value, you lose. After the point value has been matched, or a 7 terminates the game, the play resumes from the top. The following sequence of dice rolls gives the results. 7, a player wins. If they roll a 4, 5, 3, then 7, the player loses. If they roll an 8, 6, 2, then 8, the player wins. If they roll a 3, then they lose. If you want to see the full program, you can look at a handout in Lesson 14 online. The application of De Morgan's laws occur in the getPoint method. Do-while loop has a compound exit condition. When developing a conditional loop, it is very helpful to think about the assertions that are true when the loop will be finished. In other words, when the loop is done, what will be true? When the loop in getPoint is done, one of two things will be true. The point will be matched, or 7 has been rolled. These two statements can be combined into one summary assertion statement. The loop assertion statements will be true when the loop is done. Once you have established the loop assertion, writing a boundary condition involves a simple negation of loop assertion. Taking the assertion developed, the negation of the assertion follows. Applying De Morgan's law results in this, and rewriting each of the expression will give you this. Looking at the first half of the developing boundary condition, the statement means that we have not yet met the match point. In other words, we haven't won yet. The second half of the boundary condition means we have not yet crapped out. In other words, we haven't lost yet, so we must keep rolling the dice. Some Boolean expressions are equivalent and interchangeable. Choose one that you think makes your code easier to read.